10.2 is us talking about parabolas again. We've talked about them before, how they have a vertex, which is a highest or lowest point. In this case here, it's a lowest point. They have an axis of symmetry, which we call an AOS, that cuts the parabola in half. There's other things, but two new things we'll talk about are a focus and a directrix, two new pieces of a parabola to explore. So let's talk about this here. We have a focus, which just means some given point, and a directrix, which really just means some given line. And the question that's really posed is, if I could put a point that has the same distance between the focus and the directrix, where would those points be? I'm sure there's a lot of them. Like, for example, if I went exactly halfway between, and that might not be halfway between, but suppose this is halfway between, the distance from here to here and the distance from here to here, those would be the same distances. And if I go over here and maybe like here put a point, this distance here and this distance here are ideally the same. And then maybe I go like diagonal, so way up here there might be a point that has where this distance here and this distance are the same. But the point is there's a lot of these points. In fact, there's an infinite number of these points that are equidistant, have the same distance from a given point and a given line. So let's find a way to actually find all those points. I've set up this little tool here. This point P, you can see the distance from F to P is 1.64, and D to P is 1.64. This is the same distance between. And as I move this point D, the distance from the point to the line and the distance from the point to the line, or to the focus, are the same. And I can keep moving this point D around, and this relationship stays the same. If I could trace this point, well, not if I could, I will. I'll trace the point. As I trace it, you'll see it forms a parabola. Not a circle like you might have thought, actually, but it forms a parabola. You probably didn't think it was just going to be a circle because this section's on parabolas. If I take the focus and I move it farther away, this little line appears up, but ignore that. The parabola gets wider. If I take the focus and move it closer, the parabola obviously gets more narrow. Here's a very narrow parabola. I can move the focus underneath the directrix, and now it's all going to flip sides. The parabola's over here. And then what's also pretty fun is I can actually just change the angle of this line here. If I go at a really tight angle like this, I'll erase all these traces. Now the parabola has this angle here. In fact, I could twist it all the way to get it on its side. Here's a parabola that I have, but I could take that parabola and twist it all the way over onto its side. Not really any place that I want it, move that parabola around and keep that relationship of biggest to smallest. So, sorry, there's a nice little picture of my baby. A parabola is the shape that is found by finding all points equidistant from the focus and the directrix. If you were to pick any point on a parabola, it'd be the same distance from the focus and the directrix, that point and that line. And the vertex of a parabola is halfway between the focus and the directrix. That one right there, this line right here, is really useful. But the vertex is halfway between the focus and the directrix. That was a weird way for me to box that. Here is a table of information that I'll give you on quizzes and tests, and it's in your book on page 623, and it's very, very, very useful. You'll notice that this equation here is one you've seen before. This is just a vertex form of a parabola. If A is positive, graph goes up. If A is negative, graph goes down. The vertex is the point HK. The AOS is through the vertex at the line x equals h. These two things here are new. They involve some simple addition and division, but they're not so bad. Here's the point HK. Now the difference is over here. It's x equals. Oh, that's crazy. When you have an x equals, basically what's actually more important is when the y is being squared. That's when the parabolas are on their sides. Point to the right or point to the left. If a value is positive, it points right. If a value is negative, it points left. You'll notice that k and h are in opposite spots. It's no longer hk, it's kh, but they still do the same things. H still moves things left to right. K still moves things up and down. And so the AOS is y equals k, and you got these formulas here to play with. I'll go through 3 examples of how to work with these equations and these parabolas to sort of see what we're looking at. So I'm going to find the vertex, the AOS, the focus, and the directrix, and I'm going to graph this parabola. It's really helpful to find all of these things before I try and start graphing it. So that's what I'm going to do. Since it's an x equals equation, really since the y is being squared, I know then I'm dealing with this stuff over here. I'm doing this box on the right, where my parabola is going to be on its left or on its right, pointing to the side. Since the a value is positive, since the a value is 2, I know the parabola is going to point to the right, because that is the positive direction on the x-axis. My h value is now 1, and my k value is 4. Not -4, but 4, because you do the opposites. Just like over here, we would grab the opposite of h. Now we're grabbing the opposite of k. Pull this grid down, pull these things over here. So first I'll find the vertex. The vertex is the easiest thing to find. It's just the point hk. So the vertex is the point 1, 4. I'm not going to graph it yet, and you'll see why in a little bit. Then I'll find the AOS. The AOS is the line y equals k. Well, y equals k in this case is just y equals 4. So there's my axis of symmetry, y equals 4. The focus involves a little bit of arithmetic, but it's really not too bad. Focus, I'm going to do h plus 1 over 4a. Well, my h value is 1, my a value is 2. Sorry, I'm being crazy here. 1 over 4a. Which is 1 1/8, or 1.125. So my focus has two pieces, an x and a y coordinate. I just found the x coordinate, 1.125. The y coordinate is k, and my k value is 4. And then I'll come down here and I'll find the directrix. The directrix is 1h minus 1 over 4a, which is going to be 1 minus 1 over 8, which is 0.82, 0.875. So that's the line x equals 0.875. These are the 4 things I have to really graph and work with before I can make my parabola. Now here's what's really, really annoying about these things. These numbers are small, and they're a pain to work with. So what I really strongly recommend is you just go to the middle of your graph. Wherever the middle of your graph is, put a point there. And have that middle of your graph always, always, always be the focus. Yeah, it could be the directrix, it could be anything, it doesn't matter. For this case, I'm going to go with the focus. That middle of my graph is the focus, and that's 1.125. So small you can't even see it, so I'll make it bigger. 1.125, 4. It's just this right here, 1.125, 4. Well then what's weird about this is I don't want to count by ones anymore. I always want to have my scale count by whatever 1 over 4a is. In this case, 1 over 8. I want my scale to count by 1/8. So this is 1 1/8. So this would just be 1. And I can go back 1, 2, 3, 4. And this is a half. I'm trying to explain that as best I can because I know that counting by fractions is a bit odd. But if I'm counting by 1/8 and I'm going by the middle here, so this point right here is really 1 and 1/8. And this would be 1, and this would be 7/8, and 6/8, and 5/8, and 4/8, and 3/8, and that's my x scale. On the y's, I'm going to do the same thing, but I know this is the point 4, so if that's 4, then I'll count by 8. So there's 3 and 7/8, and 3 and 6/8, and 3 and 5/8. So here's 3 and 4/8, or 3.5. And 4 and 1/8, 4 and 2/8, 4 and 3/8, 4 and 4/8 is 4.5. And that's how my grid is going to look. That's my scale. It's odd and weird to get used to, but once you get that scale figured out, everything else falls into place really quickly. So let me start graphing other things. I will graph the axis of symmetry. That's the line y equals 4. We'll actually do that with the dotted line. The AOS y equals 4 is right here. Half my parabola will be above that, half my parabola will be below that. The vertex is at the point 1, 4. We'll do that in purple. The point 1, 4 is here. There's the point 1, 4. That is my vertex. Then the directrix is going to be at line x equals 0.875. Well, 0.875 is really 7/8. It's just this one here. This right here is my directrix. At this point, I've put down everything that I can put down in terms of information. I have a vertex, I have a focus, I have an AOS, I have everything. The focus, you'll remember, was this green one right here. Well, the graph itself, the parabola itself, actually involves the purple V. And there's a couple things you can do to help yourself out. One thing is I know that the distance from here to here was 2. And whatever that distance is there, in that case it was 2. I'm going to go up 2 and down 2 and put some points there. Put a point here and put a point here. The reason that I do that is now this distance from here to here is 2, and this from here to here is 2, and that's good, same, and these have the same distance also. So I get that little T, I think there's a term for that called the latest rectum that your book might use it, I don't really show, but I get that T there. At this point, if you wanted to find other points, you can actually just plug stuff in for y. And this is what's very convenient about having an equation. I have an equation up here that says x equals something, so I can plug stuff in for y. I have a y value at 4 1/4. I wonder what's the y value at 4 1/2. So I can plug in 4.5 for y and see what I get out for x. I'm going to pull up my calculator and pause for a second. Now, as you know, I can't do an x equals in my calculator, but I can still calculate 2 times 4.5 minus 4 squared plus 1. I can still calculate this in my equation, and I get 1.5. So the y coordinate was 4.5. The x coordinate was 1.5. So I'll go to 1.5, which is going to be, this is 1 1/8, 1 2/8, 1 3/8, 1 4/8. Here's 1.5. And I had the point 4.5, which is way up here. And so I'll also go to a point here. Now, if this seems confusing to you, please understand that A, it is confusing at first. You'll get the hang of it. But B, this is a fairly hard one for me to start on. I like to do that because it gives us an idea of how dirty these can get. The ones we do in the next examples will be simpler and easier. But notice how I drew the purple parabola on its side, because I knew this parabola would be on its side, because it was an x equals equation with a positive a value, and that's a parabola on its side. Okay, we'll do something else, a little bit different. Same game though. We'll just screen down one and go here. I'm going to write the equation of a parabola given some information. I know the parabola has a focus at a point 2,8 and a directrix at the point x equals 6. Well, it's helpful to find h and k right away. If my focus is at 2,8 and my directrix is at x equals 6, I don't really know immediately if this is going to point up and down or left and right. So what I find really helpful is to graph it. So like I said, in the middle of my table, or middle of my chart here, I'm just going to put the point 2,8. I don't really care how that looks on my graph. That's a point 2,8, which really means I can draw an axis now. I could have the x-axis here. There's an x value of 2, and if that's at 8, it'd go 1, 2, 3, 4, 5, 6, 7. The y-axis would be like there somewhere. There's the point 2,8. That's my focus, not my vertex, but my focus. The directrix is at the line x equals 6. Well, I will graph this in blue. If the directrix is x equals 6, that's going to be right there. That is my directrix. So now I know the parabola is going to be facing up. In fact, I could have told that earlier. If the directrix is an x equals equation, Oh, wait a second. I drew that wrong. The directrix is an x equals equation. It should be going in the direction. I apologize. This thing over here. Entirely, actually. X equals 6 would be 1, 2, 3, 4, 5, 6 right here. This is the line x equals 6. So, since an x equals, gosh, great, an x equals, we know it's pointing either left or pointing right. The question is it pointing left or right? Well, since this is the focus right here, I know my parabola will always enclose the focus. So I know the parabola is going to look something kind of like this. So I actually know that I'm going to have a negative a value. Now I've got to find them. Well, if the vertex is at the point 2, or the focus is at the point 2, 8, I could do some algebra here and solve that a little bit. I can plug in a 2 for h and an 8 for k. Take that back. I'm going to back off that for a second. I'm going to play with this graph a little bit longer first. The vertex, I know, is going to be halfway between. The vertex is halfway between the focus and the directrix. So my vertex is going to be right here. That's the point 4, 8. My vertex is at the point 4, 8. And that gives me h, and that gives me k. My h value is 4. My k value is 8. For the record, if I wanted to finish this graph, which I don't need to, but remember, this goes 4 here, so I go up 4 and down 4. Put points there. If I really wanted to, I could plug other numbers in for y and calculate x. I don't have an equation, never mind, I can't do that. This parabola is going to look something kind of like this. You don't actually need that, but I think it's worth me showing how that works. We'll stick here. Now that I know that h and k are 4 and 8, I can calculate everything else. I can find, based on my, I'll pick this one. I know the directrix is at x equals 6. The directrix is at x equals 6. But I also know that h minus 1 over 4a is going to equal 6. So, since my directrix is 6, I can get this equation right here. I can plug my h value in of 4. So it's 4 minus 1 over 4a equals 6. And I solve that equation. Subtract 4 from both sides. Multiply both sides by negative 4a. Divide both sides by negative 8. And a equals negative 1 over 8. Your a values will be fractions pretty often, actually. It's really nice when the a values are fractions. It's easier. So the equation, which is what this is asking for, is y equals negative 1 over 8 times, I'm sorry, this is x equals, I'm doing this stuff over here, x equals negative 1 over 8 times y minus k, which is minus 8 squared plus 4. There is your equation. Box is kind of full. There is, however, one other way you can find this a value, and this is kind of the pro way. The a value is always the same as this distance right here. This was 8. I went down 4 and down 4. That's the distance of 8, which means it's really always double this distance here, which really means it's 4 times that distance there, if you want to think about that. But if you can ever find this long t side, that's your a value, and you put it over 1. 1 over 8, because this was 8. We'll see examples of that in class. Okay, last one. Put this down so you can see it. Find the vertex, focus, directrix, axis of symmetry, and graph. 1/3 times x plus 2 squared minus 4. Well, this one is actually going to be one I'm more familiar with. This is in this form. So this is going to be pointing up because the a value is positive. I know the vertex is at the point -2, -4. I know my A value is 1/3. And I know that my axis of symmetry is the line x equals h. So the AOS is the line x equals -2. And my focus is going to be at h. Well, first of all, let's see if I can find the focus without calculating it. I think I'm just going to count by ones and see what happens. I should probably count by halves. Here's what I'm saying I should count by halves. If I do 1/4a, that's 1/4 and a third, which is really 3/4, 0.75. So if I count by 0.75, this will work out fine. To make it easier, I'm going to count by 0.25s. Maybe I should keep that way. I'm going to count by 0.25s. Since I know where the vertex is, -2, -4, I'll put that here. If I'm counting by 0.25s, there's -2, -1.5, -1, -1/2, 0. Zero's going to be basically here. On the x, I know that's at -4. So if that's -4, then here's -3.5. So here's -3, and here's -2.5, and here's -2. And I can't really fit the y-axis on there. Not well, at least I've got those points. Now, my vertex is at -2, 4, and my AOS is at x equals -2. So my AOS is going to be this line right here. This is the line cutting my graph in half, so I know that's pointing up. So I've got to find the directrix. Remember how I said that the A value right here, the A value is 1/, the distance through the vertex. So I should get the focus, I suppose. Hang up on that for a second. Find the focus. I'll come back and find the focus first. To find the focus, I look here, h comma k plus 1/4a. My h value is -2, the k value is -4. So it's -2 comma -4 plus 1/3/4. Nope, 4/3. And 1/4 is just 3/4. So it's really -2 comma -4 plus 3/4, which is -2 comma -3.25. So my focus is going to be 1, 2, 3, 4. Here's -3, so 3.25. It's going to be right there. There is my focus. Well, here's my vertex. Here's my focus. Since this distance here was 1, 2, 3, 4, 5 boxes, I can just count the boxes. And I can go 1, 2, 3, 4, 5 boxes that way and get my directrix. That doesn't feel right. Give me 1 second. Yeah, I'm sorry, I plotted those points wrong. -2 comma -3.25, -2, -3.25. Would be here. -2, -3.5. Here's -3, so here's -5. So -2, -3.25 is here. There is my focus. Here was my vertex. So the directrix, I can count boxes now. This is 1, 2, 3 boxes. This right here is 1, 2, 3 boxes. That's my directrix. It's got to be the same distance from the focus to the vertex as vertex to the directrix. Now this is 6. Is it this? Goes 6, and this goes 6, and I have a point here and here, and there's my parabola. Okay, that was not my best work, but we'll have to do with it for now. We'll talk about it more in class. Thanks for sticking with that one. They're all going to be kind of long this chapter. That's not true. The circle one will be way shorter. So will the ellipse one.